For the Day 13 assessment, you need to do a task that looks slightly different from the things you've done before. Given a list of string literals, you want to find out how many times a specific value, in this case b, appears immediately following another value, a. And the trouble is, we've done loops before which allowed you to do something for every element in the list. But this one is a little different because I have to do something based upon the order of a element compared to another element. As soon as you see that, you should recognize that you have to do a specific kind of for loop. Let me show you here. So I want to count b following a, given a list of string literals. And this will return the count of how many times a b appears immediately after an a. Great. To make this work, I have to set up a for loop. And you've seen this before for some s in strings. Now what would I do? Well, I'll just do something simple here. I'll print it out. So if I pass in this with a particular string list, I'll just call them A, B, and then C, for example. Count B following. Well, it's going to print out each one at a time. Now what I want to do is find out how many times the value B appears immediately following a value A. This is the second element in the list, therefore it can be immediately following the first one in the list. When you see that you have to be dealing with the index positions, you have to change from a simple iteration over every element into one that gives you the index positions. And you've seen this structure before for I in range of len of the list. Now if I were to do this here, you would see how I would print out strings of I. That's how you would deal with that particular situation. So I get the same information that you see before, and I want to do something specifically when I see a B immediately following an A. Okay. To do that, I have to check to see whether the particular value at strings of I, is it a B, and then I have to check if this position just to the left of it, or strings of I minus 1, is an A. So if I ever see that strings of I is equal to a B, and strings of I minus 1 is ever equal to an A, then I know that I've seen the specific pattern that I was looking for. So I'll increment my count number. You may have seen me. Let's do it this way. I'll start off assuming that I have a number 0, that this doesn't actually occur any time in the list. And then I'll return my number here. So now, this looks like it's got everything that I want. I'm going to do something for every index position in the list. If this index position is a B and the one to its left is an A, I want to increment my count of numbers that I've seen. But when I do this, what you do, you see this set up as follows. So B, index position 0, is it equal to strings of, in this case, 0 minus 1, which is negative 1. In Python, one of the things they did is a really novel feature of the language. Normally when you have a list, as you see here, the 0th one is A, as you can imagine. That's the first element in the list. And then the second one is words of 1, and so on. They have this really nice idea that's only in Python, is what if you want to have the element at the end of the list, the very last element. You've seen me use the structure before. To find the last element in a list, you find the index position of the length of the list minus 1. In this case, C. However, Python has this really nice novelty, where if you look for the index position negative 1, it actually counts from the end of the list. In fact, if you pass in a negative number, it counts from the end of the list backwards. So this is really not what I wanted after all, because in my original list, yes, this happens exactly once, that a B follows an A. But if I pass in this as my list, I'm going to start with a B, then I'll have a C, then an A. If you look at this, you say, well, look, a B never follows an A. Unfortunately, B following will still return 1 because this B, the 0th element, is in fact following the negative first element, which is this A here. So we have to be a little bit smart. I know I want to check this, but only for the second and remaining elements. And to do that, we just change the list and the range so that I say for I in range of 1 up until len of strings. And so now here, this will return 0 because after all in this list, the B does not immediately follow an A. But if I pass in my original list, which was A, and then B, and then C, you'll see how many times I see that? It's 1. So this covered a number of specific cases. You see a for loop, and when you see you've got to compare index positions, you have to do the for I in range of len of string. However, we have to be careful about how we look at neighboring elements. And to do that properly, we skip the 0th one the first time through the loop because there is no preceding element before it. We're going to start from the first one, which is, as you see here, index position 1. That's the second element in the list, and go all the way to the end. And then, if I see the condition I'm looking for, I can increment my count, and then I'm done. The structure is the same as you've seen for other functions, defining an integer count and then returning it at the end. Please review this if you have any questions about this novelty about index position -1, and review the lecture notes where I talk about that. This completes the assessment for day 13.